is a number of things. It's a foundation, it's a software project, it's a community. And I'm going to be talking about all three of these things. My day job is kind of a community manager sort of position, although I don't pretend to manage the community. And as a result of that, my knowledge of OpenStack is very broad and a little bit shallow. So I'm hoping to give you an overview of how all of this fits together, and then I will defer deep technical questions a little bit further upstream. So OpenStack is about 4 years old now, and it came out of necessity, as do all great open source projects. There were two organizations that were facing similar problems of scale, and those of you that were in my presentation yesterday have heard a little bit of this already. NASA was one of those organizations, and NASA was doing their computing in the Amazon cloud, and one of the things that they were computing on was photographs that they were taking in deep space. The Amazon cloud was limiting them to about 1 terabyte for each of their images. They were getting about 20 terabyte photographs several times a minute from space. And so it was going to take them a couple years to upload a day's worth of photographs to Amazon to do their calculation, which wasn't quite fast enough. So they were doing some research about how to handle this internally. Meanwhile, Rackspace, one of our great sponsors here at this event, was having a similar question of scale on terms of computing. They had millions of customers wanting to spin up and spin down cloud instances every minute, every day, and they wanted a way to manage that more effectively than having lots of monkeys pressing buttons. And so these two folks met up at an event and said, hey, we're solving similar problems, let's get together. 4 years on, there are around 300 companies that are involved. This is a tiny portion of the list. This is a screenshot about halfway down the page of some of the companies. Well, I guess it's close to the top, isn't it? This is A through F. And there are about 300 companies that are involved at different levels of financial support or of technical support. It's a really cool organization to be part of because the technical management is done by the community, not by NASA saying this is what you need to implement, but it's all of these different organizations operating on an equal footing so that a company like my own organization, Red Hat, that has a large number of engineers involved, doesn't have any more say than a smaller company that just has 1 or 2 engineers involved. It's the best ideas winning. So it's a really cool project from an open source perspective. The governance, as I said, it's vendor neutral. Each project, and I'll talk a little bit more about the projects in a minute, each project appoints a technical leader for their project. And that's not something that you get for free because you sponsor the foundation. It's elected by the individual communities so that the decisions are made on a technical footing rather than a political footing. Some of the things that the OpenStack Foundation provides are these things. Infrastructure support is kind of a big deal. And toward the end of the talk, I'm going to show you something about the testing infrastructure. The testing infrastructure is absolutely insane. It's so cool. Then there's community manager services. There's a team of community folks led by Stefano Mafuli that do community manager type things for user groups, meetups, and all of the various social media that goes along with that. Stefano's got a full-time job doing that. And then we also have 2 major conferences every year. It's called the OpenStack Summit, and the primary purpose for that is to plan the next release, but there's also a technical content for learning that goes along with that. One of the other aspects of the OpenStack project is this notion of incubation. And so what we're hoping to produce out of OpenStack is a usable system for spinning up a cloud. And so we want to ensure that each part of that stack is reliable. Now, in the early days, there was the compute engine and the storage engine and the networking, and that's all that there was. But as time has gone by, numerous other projects have come along providing other portions of a full cloud solution. And the incubation period ensures that before a project actually becomes part of the official release, it is actually measuring up to the standards of the community as a whole. And one of the cool things about the incubation project is that a year ago, the standards for incubation were considerably raised so that a project had to pass a higher bar. But that wasn't good enough. We actually went back to the projects that had already graduated and said, you need to pass this bar as well. So there's a recertification to ensure that there's no resting on laurels of projects that are already part of that. I'm going to show you some of the projects that are involved in this in a moment. So OpenStack is a stack of different components that provide a cloud infrastructure where you've got compute and storage and networking, and then also there is a dashboard that lets you manage this, and then there's a comprehensive API that lets you manage this. Now, the dashboard's cool for clicking around and launching virtual machines and all that, but in the real world, where you actually have large scale, the API is going to be the way that you're going to manage that. And so the API is the first tier customer in all of these projects. The primary communication is over the API. The dashboard itself is just a thin layer on top of the API, because we assume that everyone is going to be using the API primarily. Now, there's a couple definitions that if you haven't seen these definitions before, it's important to understand what we're talking about when we say cloud. These are the 5 components of the definition of cloud. There's the on-demand self-service, and that means that if I want to launch a virtual machine, I don't have to pick up the phone and talk to somebody. I just have to click a button and it happens. And it happens now rather than 3 months from now when I get manager sign-off. Broad network access means all of this stuff is available via the network. And that might mean your internal network, but it might mean the internet. Resource pooling means that there is a large source of resources that everyone has access to, whether that's hardware or the networking or the storage, and that can be doled out as needed to the various instances. Rapid elasticity is a very important aspect, and this means that you're able to scale up and down on demand, so that you build your infrastructure, and then when Black Friday comes and your sales shoot through the roof, your servers don't crash, they automatically spool up more. But then when you're done, they go away, so you're not continuing to pay for resources once you don't need them anymore. And then finally, there's measured service, and that means the ability to send somebody a bill. This is the metering that says who's using how much when and for what. And so you can bill based on CPU time or storage time or whatever you choose, but that is all being metered as you go. OpenStack is what's referred to as infrastructure as a service. So if you can think about how things were 10 years ago, 15 years ago, you were all the way on the left there. You were responsible for everything from the physical hardware and plugging the cables into it all the way up to the code layer where your web application was running. You were responsible for the whole thing. And as time went by, there were different layers that were available here, all the way up to software as a service, which is where you open up your browser and read your Gmail, and you don't care that there is a smelly, dusty server somewhere that's actually sitting on. OpenStack is at the infrastructure as a service layer, so that the OpenStack is responsible for everything up to the virtualization layer, and then your customers, whether that's paying customers or whether that's the people within your company, they're responsible for the OS layer and everything that's up above that. Platform as a service is something like OpenShift, where you're simply deploying an application and you don't care about the operating system. Another way to look at the cloud world, this is one of the favorite analogies that you see bandied about, is pets versus cattle. Okay, so when you have a pet, it has a name. Its name is Fluffy. And when Fluffy gets sick, you take Fluffy to the vet and you help Fluffy get better. You take care of your servers. Each one is completely different from the others, and so you have to patch them separately. And there's a lot of management involved. And this is appropriate when you're a small organization with 100 servers. The next layer is the cattle server, the cattle analogy here. They have names that don't mean anything except that they're some kind of an ID number. They might refer to, this particular one is a server that's in rack number 1 in my Washington, D.C. facility, and it's got some kind of a ID number on it. When a server gets sick, you throw it away and you replace it with a new one that's exactly the same, because there's no difference between them. Now, sometimes you have pets, in your business, and sometimes you have cattle, and both of these are important, relevant models. But this is the one that OpenStack is more interested in. And, when you have a pet, you teach it specific tricks. Each one of your pets does a particular thing. But when you're an organization like, say, CERN, who is one of our favorite end users, you have 70,000 servers out there that are all responsible for doing data crunching on the numbers that you're getting from your particle accelerator. And if one of them goes down, you don't have the time to make it better. You just spin up a new one. And so spinning up a new one, I'm starting to talk really fast, and I'm going to be done in 20 minutes, and then that's no fun. So spin up a new one generally means that there's something automated. Automation is an important part of OpenStack. There's a component called heat that does orchestration, and it can do things like watch my instances. When the average utilization goes above 30%, spin up another 10. And that all happens automatically and doesn't require any human intervention. So that's kind of some definitions there. Here's how OpenStack itself sort of fits together. Now this is the super simple diagram that I showed some of you yesterday. And this is the diagram from generation 1 of OpenStack, but it's a good way to start understanding how things fit together. There is the OpenStack shared services, and that's sort of the message bus. That's how the services communicate with one another. And running on top of that, you have these 3 critical components. Compute, that's where your virtual machines actually live and run. You have the networking, which is networking as a service, software-based networking. And then you have storage, which is your Ceph or Gluster or whatever farm of disks where your data is actually going, and that gets provided to the compute layer for them to use as storage. And then these all communicate with one another over the API. The dashboard over there is a web-based control interface, which is just talking to the API. Now, as time went on, other components were added to this system. And so here are some of the things that are now part of the system. You've still got this basic layer 1. Compute is still the main thing that you're going to be interested in most of the time. There's an identity portion, which means authentication. And that might be your existing LDAP backend at your company. It might be its own standalone database of authentication records. Glance is images. And then you have these other layers which are increasingly more optional as you go up. And you may choose to have any one of these components or none of them. There are organizations that just use Swift to manage their storage, and they don't use any of the other components. So you can use any one of these in conjunction with others or all by itself. I'm going to give you a quick overview of all the projects that exist right now. There will be a test at the end. These are in alphabetical order, which is, of course, the most obvious order to talk about compute resources. Bare metal is ironic. So there's two things here. There is what the service does, and then there's a code name. And some of these code names are clever, and some of them are inscrutable. But ironic is one of my favorites. Ironic is the layer that allows you to deploy physical machines as though they were virtual machines. Now, it sounds a little bit weird, but it's one of the places where I've seen this used is where you have an enormous rack of tiny little ARM boxes, and you treat each one of your ARM machines as though it were a virtual machine. You manage them as though they're virtual machines, so it gives you the management interface, but behind each virtual machine there's actually this little Raspberry Pi, so that's really cool. Block storage is your server disks. That's called Cinder. Oslo is an abstraction that pulls out a lot of the common libraries that have been used all across the board that had been duplicated prior to Oslo's showing up on the scene. Nova, the name comes from NASA. Nova was the one that came out of OpenStack. But this is the compute layer. DNS as a service is the Designate project. Dashboard, the Horizon is the web dashboard. Sahara is a fairly new project that allows you to deploy Hadoop automatically on OpenStack. So you could have an enormous Hadoop cluster scaling as your data needs increase. That's still kind of young, but it's a really exciting project to watch. Trove is another one that allows you to do database pooling, and that can have PostgreSQL or MySQL behind it, and allows you to provide database as a service to your VMs. That's another one that's fairly new but incredibly fast moving. Deployment is difficult on OpenStack, as you can imagine, and as many of you have come and talked to me about at the booth. Deployment's hard because you've got all of these different processes that have to talk to each other. So OOO is an effort to provide a mechanism for deploying these things without losing your mind. The documentation project doesn't have a clever name, but is one of the most important parts of the OpenStack community, because without that we wouldn't know how to use anything. Keystone, authentication, and there's more. Glance is the image service. Now, I mentioned a moment ago that Cinder was the block storage. So these are two different things, two types of storage. Block storage is like your hard drive on your server. Image storage is where you put your virtual machine images and snapshots. And so when you boot up a machine, it talks to Glance to get the image that you're going to boot up. And you can save snapshots there. You can create backups using Glance to store snapshots. The infrastructure project I'm going to talk more about later. Key management is the security project. There's a message service. There's the networking. Networking is something that tends to be the most difficult part of OpenStack. And the Neutron project is steadily trying to make that easier. Not as fast as some of us would hope, because if you look at ask.openstack.org, which is our community question and answer site, I would say 75% of the questions on there are about networking. And it's complicated. Let's see, what else? Object storage, which is, again, a different thing from image storage, and this gives you a different way to do your storage. This is where you would do maybe Ceph or Gluster as an object storage backend. and orchestration, quality assurance, release management. Manila is a brand new project that I don't know much about yet. And then there is Ceilometer. And there's more. So last week, yes? Yeah.
Okay, all right.
Yep. So last week, the technical committee of OpenStack had some meetings and have made some decisions about the future direction of OpenStack. And it's still early days in this, so it's not entirely clear what the implications are going to be. But if you look at this list, you'll notice that there is the official name, networking, and then there's the code name, Neutron. If you read the documentation does not talk about Neutron. It talks about networking. It's the official name, and it's the name that the team calls themselves. But the implication there is, yes?
Could you just comment on the name change for method service from Marconi?
It was the name change from Marconi to Zakar was a trademark question. We were just asked to pick a different name. And Zakar is the messenger of the gods in ancient Sumerian mythology. So it's actually a really cool name. So one of the decisions of the technical committee was that, so I was saying networking implies that there's only one networking project. And if you want to come up with a different networking project, go do it somewhere else. One of the decisions of the technical committee last week was we should allow some competition here. So we're not going to call it networking anymore. We're going to call it Neutron. That's now the official name of the project. And if somebody else comes up with a different networking project, more power to them. That sounds great off the top. I think it's going to cause some complexity in the community in the days to come, but I think that in the long run it's going to be to the benefit of all of us because it's going to provide a situation where better ideas are allowed to win and different ideas are allowed to coexist and you can pick the one that works best for you. It's going to be an exciting year. Oh, I'm sorry, I had a slide about that. So what else did we say in that meeting? Also, we've got this 6-month release cadence, which means that every one of these 30 projects has to release on the same cadence, which doesn't necessarily make sense to everybody. And so that's something that's being changed as well in the coming months. So we'll see. This will be something to watch. Come to my presentation next year, and you'll see how it turned out. I'm going to talk a little bit more in depth about some of these services within OpenStack. And something to note about all of these services. So DevStack is a tool that's provided by the OpenStack community itself. It's primarily, it came out of the testing team. And so it's focused on testing and development, hence the name, DevStack. It deploys OpenStack directly out of Git. You point it at a particular branch, which is usually the development head, and it deploys directly out of there for testing purposes, so you can see what's broken. But you can also point it at a released branch, and that would allow you to deploy something that should presumably actually work. You run stack.sh, and it does all of this stuff that you can't read from the back, but this is, it's running Puppet scripts that are standing up the various services and getting them to talk to one another. And so you run stack.sh, and 15, 20 minutes later you have this functioning stack, or not, depending on what branch you're pulling from. And then that allows you to do your development. And then when it's done, it tells you how long it ran. So this one ran in 1688 seconds. So I don't know, figure that out, how long that was, 10, 15 minutes. This looks like a misplaced slide. But anyway, this is an instance that's running on something that I deployed out of DevStack, So this just kind of just worked right out of the box. Yes?
How do you manage all the logs within your components, what's going on? There's so many services running. Can you hook into like Logstash, Elasticsearch?
You can.
Project for logging?
Yeah, Elasticsearch has a presentation, I think, at this event about logging with OpenStack. I may be thinking of a different event, but they do have a solution for that, and Logstash has quite a lot of documentation about how to do OpenStack logging through Logstash. And of course, the larger your cloud gets, the more you need something like that, because, yeah. The project that I work on is RDO, and it is specifically packages for CentOS and Fedora and Red Hat Enterprise Linux. And so this is the process for installing that on a CentOS machine. So essentially we provide the Yum repository and a utility called Packstack, which is, again, Puppet modules. But the difference between this and DevStack is that we're packaging stable releases rather than pulling directly out of Git. And so this is hopefully going to work more frequently than DevStack will, but they're very similar approaches. And then, we've also got a community of folks that will commiserate with you when it doesn't work and hopefully walk you through the process of fixing that. And then there are others. Helion has a big booth at this event, and that's another option for deploying and managing OpenStack. Crowbar, I haven't heard much about Crowbar recently, but that was something that was out of Dell. And then Fuel, there's another company called Mirantis, which produces a tool called Fuel, it's pretty slick. It does a lot of auto-discovery of what's out on your network and does Pixie boot and brings up those machines. Which leads to the obvious question, why there's so many of this. I mentioned earlier that OOO is one of the projects that's focused on deployment. OOO is pretty new, and as OOO matures, maybe the need for all of these third-party deployment tools will diminish. I don't know. We'll see. But there are also lots of local variants. I mean, how many of us anymore fetch the Linux source code and build our own kernels? I'm sure some of you people do. This is the event for it. But most of us deploy a distribution that someone has gone to the trouble to build, and that's what we do at RDO. We're building and testing a distribution so that takes some of the pain out of that process. Another place where there's quite a bit of competition right now is a management interface for doing multi-cloud management. So, for example, there's ManageIQ that allows you to manage your OpenStack and CloudStack and Amazon and OpenNebula instance from a single management interface. So that's something cool to watch. I'm trying to figure out how much time I actually have left. Not a whole lot, right? So ask.openstack.org is the place to go when you have difficulty with OpenStack. There are, yes?
I'd like to ask, take a large but not CERN or NASA, how many Red Hat Enterprise Linux licenses would they need? I'm just trying to understand why you have so many flavors.
I'm not able to answer licensing questions. I'm sorry. It's just not something I know something about.
That's why you go with CentOS. I look at Red Hat as the industrial.
Mm-hmm.
And Fedora's pretty good too.
So Red Hat does have a commercial solution, but I'm specifically not here to make a product pitch, and so perhaps we can take that offline afterwards. All right, sure. So ask.openstack.org is the place to go if you have questions about OpenStack. There are hundreds of OpenStack engineers that answer the majority of these questions within the first couple hours. And so it's really a great place to go, both to ask your questions and to look for questions that have already been answered The answers tend to be thoroughly documented. And then this guy right here, this is Stefano Mafuli, and he's the OpenStack community manager, and he watches this like a hawk, and if he sees something going unanswered, he tries to actually actively find somebody to come and answer that question. So it's a really helpful site. Testing has been a major component of OpenStack, the foundation, from the beginning. The OpenStack Foundation employs a number of full-time testing engineers that do this. And they've developed, so they started out using sort of off-the-shelf CI software, and it wasn't quite good enough, didn't go fast enough for what they needed, and they developed this testing infrastructure called Zool. And Zool is pretty amazing. Unfortunately, I got this screenshot as we came into the weekend. And so what you see on the left-hand side of the graph is a typical Friday evening load on the servers. Now, I know that that's kind of squinty from the back, but the numbers on the left, at the top left graph, represent how many virtual machines are actually running in the test environment. And this is on a Friday evening. We're running 400 to 500 virtual machines, each of which is executing the test suite. If you get this screenshot a little closer to the middle of the week, it's roughly double this. And at any given time, we are spinning up or killing hundreds of virtual machines that are running the test suite. And so this testing infrastructure is absolutely amazing. Every time that a patch comes in, it gets added to the queue, and every few minutes a new test instance, a new test suite fires off with all of the patches that have come in the meantime. And if one of them fails, the test suite's aborted, and the various people that were responsible for those patches are notified. And this all happens prior to that patch actually being given to the human reviewers that look at the style and the elegance of the solution and so forth. And so we're not wasting people's time working on patches that don't actually do anything, or don't work, rather. So I'm coming to the end of my time, I think. Two more things I want to tell you about real quickly. One is that for those of you that are deeply interested in OpenStack, we have 2 events every year. So far, there has been 1 event in North America and 1 event in the rest of the world each year. So last year, that was in Atlanta and Paris. This year, it's in Vancouver and Tokyo. And then next year, it should be back in Europe again. I'm sorry, next year. So this is in May in Vancouver. 4,000 or 5,000 OpenStack enthusiasts, and pretty much every engineer that's working on this from across the planet. So it's a really great event. The other thing that I want to mention real quick is that if you want to try OpenStack and you don't really want to spin it up on your own hardware right now, TryStack.org is the thing to write down. That's the one thing to take back from this presentation if you didn't get anything else. This allows you to use OpenStack without the pain of installing it. It allows you to explore the administrator interface. And the link, oh, I'm sorry, I'm showing the, what the heck? I see this slide here, but it's not coming up. Anyway, I'm sorry about that. I don't know why they're out of sync. TryStack.org, and back at the Red Hat booth, I've actually got a video running that shows spinning up stuff on TryStack.org and what you might be able to do there. So that's it. Any questions? I think I got about 5 minutes left.
I've got a mic for the questions, so we'll pass it along.
So if you build a beautiful OpenStack infrastructure on one of the stable releases, how long do you expect that infrastructure to last for you, where patches are going to continue to come out for it, fixes and things, before you need to build a new one? on the new
Okay, so what I can tell you as an answer is that each year we do a survey of the user community, and one of the questions that's asked in that survey is, what release are you currently running? And what we typically see is a good 20% are 4 releases back. And so that's only 2 years, and we're still very young, so people do tend to upgrade. But we see some people that are still running bare, which is, I don't know, what are we on now? We're on Kilo now, so that's like 8 releases back.
What's the process like? You typically break out part of your infrastructure and put the new release on that and then migrate it slowly with your equipment into the new?
Yeah, so the migration process can indeed be painful, but you can migrate one piece at a time, as you say. So you could migrate, say, your storage to the latest revision, and there's a backward compatibility for several releases, and so you could run your compute on one version and the other on another. That may cause some problems, but that is typically what people do. They'll upgrade one component at a time.
Rich, how would one go about getting guidance and information on the practicalities and actually a strategy to putting OpenStack on a large commercial enterprise?
Well, one of the answers would be to come to OpenStack Summit, because there are a lot of case studies that discuss exactly that. Another would be to talk to the various vendors, Red Hat and HP and Mirantis and who am I missing? The Ubuntu folks, and they have consultants that would walk you through that process and even do a proof of concept with you. So that might be one really positive way to do that.
Additional questions? Okay, so just to let you guys know, I went to the summit when it was in San Diego, and the summit's like, what, 4 or 5 times bigger than then? Right now?
Yeah, so, we had about 5,000 in Paris.
So, I mean, this is pretty big. It's growing tremendously. There's a lot of changes happening. There's a lot of stuff going on. How many of you guys are from LA? Okay, you guys, we've got an OpenStack meetup once a month. Check it out.
I should have mentioned
join us. Do we have any other OpenStack meetups in your other cities besides LA?
Yeah, there's no Stack meetup in Austin.
So Austin, Texas has an OpenStack meetup. We've got Red Hat back there, a gentleman who raised his hand asking questions out there. There's 2 in San Francisco.
Yeah, there's...
Orange County where?
Had a couple of
Okay, awesome. So we got one happening in Orange County.
If you go to meetup.com and look for OpenStack, there's 10 or 12 every night somewhere in the world.
Okay. So
thank you all for coming. Come talk to me at the Red Hat booth if you have other questions.
Let's start with Centros. A couple years